In this video, we want to use a graphing calculator to find the real zeros, the relative maxima and minima, and the range of a polynomial function. And the polynomial function that we have is g of x equals negative x to the fourth plus 3x cubed plus 20. So we can't really find the zeros of this one algebraically, at least not very easily. So we're going to use our graphing calculator to do that. So if I bring in my graphing calculator, we're going to begin by entering our function into the calculator. And I'm going to do a zoom 6 to see what we get graph-wise. And so I'm not getting a very good looking graph, but I know this graph should have a W sort of shape to it, but it's going to be upside down because the leading coefficient's negative, so that tells us it's going to be down on the left, down on the right. So I am going to adjust my window, so I need to look a little higher. Maybe we'll look up to 100, down to negative 100 with a scale of 10. Yeah, so there's our graph, and that's a pretty good looking graph. So I can find the zeros of the function by finding the x-intercepts of the graph. And so we'll do this the exact same way that we've done this previously with other kinds of functions. So I'm going to use the calc menu. So second and the trace button takes us to calc. We're going to use 0. And so if you'll remember how this works, the 0 is going to be around in there. So we're going to move to the left a little bit, give it a left bound, move to the right a little bit, give it a right bound, come back and take a guess. And so rounding to 3 places, that is negative 1.629 if I round to 3 places. So one of our zeros is negative 1.629. To find the other zero, to go through the process again, so the calc menu, number 2 for 0. So this time I want to find this one. So go to the left a little bit, go to the right a little bit, come back and take a guess. And so that is around 3.476. So 3.476 is the other zero. So in this particular case, we only have 2 zeros that are real. And so we're only going to find the real zeros. There are also 2 imaginary zeros, but we're not going to worry about those in this case. Now I also want to find any relative maxima or minima. So it looks like we have a maximum up around in here. So I'm going to use the calc menu and number 4 to find the maximum. So I'm going to move a little bit to the left of the maximum, move a little bit to the right of the maximum, and go back and take a guess. And so that maximum is around 2.25, 28.543 if I round to 3 places. So we have a maximum point of, again, about 2.250, comma, 28.543. Okay? We do not have any relative minimum or any other relative maxima. Now you might wonder about that. We're not really going to actually, like this is a quartic function, but it doesn't actually have the W shape. Like quartic functions often have a W or an M shape. This one actually just kind of curves and goes up. It doesn't actually go back down and back up. And so that's what's happening here. We only have the one maximum point. So our relative maximum is the point 2.250 and 28.543 approximately. So now again, remember, if it asks for like a maximum point, then this is the answer. This is the maximum point. But sometimes it may ask for a maximum value. In this case, the maximum value is just the y coordinate, 28.543. So like when you enter your answers into my math lab, make sure, are you supposed to enter it as a point or are you supposed to enter it as the maximum value, which would just be the 28.543 if it's the maximum value. Now that maximum value in this case relates to the range. So the domain, remember, of any polynomial function is all real numbers. So we know the domain is all real numbers. But in this case, the range, y, can never be higher than this 28.543. So our range for this particular polynomial function is that y can be anything from negative infinity up to about 28.543. I'm going to use a bracket even though that's an approximate, but it can never be above that. It's always going to be 28.543 or less, so that's the range.